Episode 2, Architectural Reviews and Threat Modeling. Welcome to the AppSec Masterclass, a podcast that helps you build an AppSec program that helps your developers build safer software, one episode at a time. Hi, I'm Jamie, a consultant for Synopsys that helps companies build their AppSec programs.
And I'm Jess, a consultant for Synopsys that helps AppSec programs implement their security solutions.
And we are here with Shandu Ketkar, the godfather of Synopsys threat modeling around here. He is the guy when it comes to ARAs and threat modeling here at SIG. He has been building and refining our threat modeling practice here for years and continues to innovate in how we model threats and attacks.
Hi, everyone, and thanks, Jamie and Jess, for inviting me on this podcast. And I don't know what to make of introducing me as Godfather. It could go either.
Well, you are.
It could go either way, but I have definitely spent a lot of time conducting threat models and architecture risk reviews. I ran the practice for a few years, so I'm really excited to talk to you guys about that.
Glad to have you here. Here's the problem that we are here to help people solve. Poorly designed software can't be scanned for. You can't point tools or DAS tools at it, SAS tools, code scanning, and say this has a design flaw. Oftentimes, code that is implemented according to spec will look correct, but it will still have vulnerabilities that go unnoticed until an attacker finds a flaw and exploits either something in the business logic or a missing control or some other item that could have been found and fixed in design. So in order to address this, we are going to talk about design reviews and threat modeling that can look for these problems and find them before the attacker even has a chance. An attack can be considered a brutal audit, where essentially the attacker puts on his auditor hat, he scans your application, he looks at it, he explores it, and based on what he's looking for, the attacker will exploit it, and eventually, if you're lucky, tell you what's wrong with minimal damage, but it can be a lot more. So just like an attacker will find and exploit gaps, a threat model can act as kind of a design audit that finds those gaps before they're exploited. So Shandu, why is that important?
I liked your analogy quite a lot. I always like to make threat modeling, which many people think is very magical. It is not. It is the most intuitive thing that we humans do day in and day out. So I always like to give an example of, I used to live in Brussels back in the day when I used to work in Brussels for a few years. And there are some areas of Brussels at that time when you parked your car, the chance that someone could steal, at that time at least, car radios were very popular in the 90s. So they would steal your car radios. So whenever I went on the weekends to visit my friends in these localities in Brussels, I would take my car radio out of the car and take it with me wherever I was going. And I did not know at that time, because I was a software developer, but I know now that what I was doing really was threat modeling. So threat modeling is something where we are anticipating threats before they occur, just like you said, audit, and take mitigative action. And then there's a lot of this jargon, assets and controls and trust zones and attack surface, but that is purely a way of formalizing things. So in the example I gave you, the asset that I was trying to protect is the car radio. The attack surface is most likely car windows or sunroof through which an attacker could get through. The security control, really mitigative security control, was to take the car radio out and take it with me. So I anticipated the threat and took mitigative action. So you start developing these things. intuitively, and intuitively, all of us understand threat modeling very well. When we translate that to software systems, then we need to formalize this domain of threat modeling within the software system domain. And that's where we start looking at things like threat modeling methodologies. So threat modeling methodologies like Stride, for example, or Synopsys' threat modeling method, they simply provide you guardrails to think like an attacker so you can start anticipating threats, start taking mitigative action before threats occur, identifying assets, identifying security controls, trust zones. But it's really in the intuitive space. That's where it begins and gets formalized using threat modeling processes.
Okay. Yeah, because intuitively, I guess anytime you recognize that there could be a problem and how you take a step back and anticipate and prevent it, I guess that's kind of the threat modeling, right? But because not everyone has the same experiences, those frameworks help to kind of inform so that way people look for the same problems in kind of the same way.
Correct. Frameworks are formalizing how we go about doing it. And just to say that most frameworks work in what I call a 3-step process.
Mm-hmm.
And Adam Shoestack talks really well about these 3 or 4 things. But the first thing is, what is it that we are building? So we start creating an abstraction or a model of the system that allows us to make intelligent security analysis of the system. So the first step is always creating a model of the system. Okay, and that answers the question, what are we building? Second thing is, what can go wrong with it? And then we come up with some type of threat analysis, such as either Stride or something else that helps us think about threats to break this model of the system that we have created. And the third step is, now that we know the threats, what can we do about what can we do about it? Do we need to fix it? Do we need to accept the risk? Do we need to do maybe something else? So transfer the risk. So the third step is, what can we do about it? So these 3 are the kind of main steps. And then you always have a feedback loop to continue to improve your process. But most methods work in a similar fashion. So Stride, for example, will model a system using data flow between 2 entities. And then it will apply 6 types of threats: spoofing, tampering, information disclosure, that type of stuff, across these data flows that cross trust boundaries. Synopsys, on the other hand, has a different way of building a model where we show not just data flows, but also control flows. We identify assets, security controls, trust zones, threat agents on the diagram, on the component diagram. And our threat analysis is a little bit more expansive than Stride, simply because the types of system we deal with. We also need to look at other types of threats, like operational threats, for example, or platform level threats, in addition to data security and data flow security threats. So we have kind of a little bit more expansive model. But ideas are really the same. We build a model of the system using some method, and then we try and attack that model using a framework or an approach that allows us to think about threats, and then we go into the mitigation aspect of it.
Okay. So Stride is a little bit, I guess, more limited in scope. When would you pick Stride or a lighter weight threat modeling framework versus a heavier weight framework, more expansive?
Yeah, so I don't want to misspeak here. Stride is not a lightweight framework.
Okay.
It is just that Stride is a really good framework. In fact, I would say it's an exceptionally well-tested framework that that is being used throughout the industry. Synopsys, on the other hand, our clients require something more than just data flow analysis and data security and data flow security analysis. So in the operational security domain, then we are also looking at things like privileged access management, patching, configuration management. So there are a lot of aspects that we have added to our threat modeling that our clients have requested over time that works for us. So Stride in no way is a lightweight threat model.
Okay.
That's the first point I want to make. The second point I want to make is, and this is from my experience, it truly does not matter which approach you choose to threat model your applications, because most of the approaches have their pros and cons. So what you need, in addition to selecting an approach, is a body of knowledge. If you don't have the body of knowledge, then you can choose the best approach and you're going to get very mediocre results, or you're going to fail in creating a threat modeling program in the long run.
So, Chandu, when you say a body of knowledge, is that about the framework itself, or is that about, let's say, the attacks that might have, or the technology, or the actual system that you're building? Like, which one that you need to have a bundle of it?
Yeah, so that's a great question. So body of knowledge is something like, let's take Stride, because everyone knows Stride. So Stride is saying that whenever a data flow crosses a trust boundary, you should think of spoofing, tampering threats. Now, spoofing is not a threat, it is a type of threat. I can spoof an interaction in many ways, depending on what I'm talking about, right? So if I'm talking about SAML protocol, I have different ways of spoofing my authentication request or response, versus if I'm talking about OIDC or a OAuth flow or a Kerberos flow. So there are different types of spoofing threats that are applicable within the application context. So unless you build a library of attack patterns, you cannot think of these spoofing threats by brainstorming. I mean, you could, it is just going to be very expensive and you would not be very consistent. So the programs that do well always build a body of knowledge, which means they have attack patterns, threat libraries, so that they understand when they're talking about certain types of systems, certain types of attackers, certain classes of threats, what threats they are talking about within their context. And they can bring those threats to bear and see if their system is equipped to handle those threats. So that's what I mean by body of knowledge. And for any good threat modeling program, you really need three things. And I may be getting ahead of myself, but body of knowledge is definitely one of them. Without that, you cannot stand up a program. The other two are, you need to have an operating model. And there we can talk about what operating model is. You need to really choose what is your threat modeling approach, who are the stakeholders, how does it integrate with your SDLC, which applications, what are the triggers for threat modeling, or at what point do you threat model, at what point you don't threat model, for example. So that's kind of the second part of your threat modeling program, body of knowledge, operating model. And the third is the delivery capability itself. And that's where there is a lot of evolution these days, because 5 years ago, threat modeling programs worked very differently. And now the move is to the delivery model is being more and more integrated into SDLC. People just want to design the right things from the get-go. They want to build the right things from the get-go. And they don't want to have an external threat modeling process that they need all the time. So there are a lot of change to the delivery model that are happening at program level today.
I guess if someone was tasked with getting that body of knowledge and making it accessible to the people who are actually running the SDLC, like how would an AppSec director go about, first of all, building that body of knowledge? Where would they find such information or sources? How would they know what sources to tap into?
Yeah, so body of knowledge, I mean, this problem exists in almost every industry, just not software security industry. So right from building industry to aviation industry to healthcare industry, this problem has been solved over and over again. And one of the key techniques of solving this problem is what they call pattern/checklist based approach. And there are two things here. One is pattern and other is a checklist. So a pattern is a commonly recurring problem whose solution you want to create once and reuse that. And a checklist is that solution. And if you look at, I mean, we all fly to our client sites as consultants. Aviation industry is rife with checklists. Okay, there is a pre-takeoff checklist, post-landing checklist. In fact, there are so many checklists in the aviation industry that when this Airbus that landed on Hudson River, I think it was Sullenberger is the pilot's name. He was the last one to come out because he was going through post-crash checklist.
Right.
And so that's the problem we have to solve, even in the security industry. So what are the common problems within our context we want to solve? So let's take a concrete example. If your organization is deploying software in AWS or some other public cloud environment, then you could start building checklists for how to use AWS cloud services in a secure manner. If you guys are using SiteMinder for authentication, you could start creating checklists for secure configuration and use of SiteMinder. If you guys are using OAuth, SAML, Kerberos, I can go on and on. Containers, Kubernetes, you can start creating, based on your context, a set of patterns that you guys are using repeatedly and start building their checklists. Now, the next question is, how does a checklist look like? And there are many ways of formatting that checklist, but effectively, you really want to capture security best practices in terms of security requirements, good design guidance, good configuration guidance, good testing guidance. So checklists can go in many, many directions. But at a minimum, I would say you should start with capturing security requirements and design guidance.
So, okay, so that's kind of the first step, is you build that body of knowledge. All right, so how do you go from there and start identifying what you need in terms of the operational model and the deployment capability?
Yeah, so operational model is where I always advise clients that body of knowledge comes before anything you do. Because if you don't have that body of knowledge, the chance that you will succeed using Stride or Synopsys threat modeling approach is almost next to nil. So you need to decide on your operating model, which means you need to understand something about the threat modeling process or the approach. And that could also include tooling, but I always like to talk about tooling at the end because tooling really is more about efficiency than about the approach. So in the operating model, there are two things we need to decide here, or at least three things. One is what threat modeling process we are using. What is our engagement model in terms of what are the triggers? Because in a typical company, there are very few new applications that are being written, but there are a lot of applications that are being updated. So you get projects that are adding new features, changing deployment, changing architecture from monolith to a microservice based or what have you. So there are a lot of updates that are going on day in and day out. So we need to build some framework that says, what are my basic conditions for invoking threat model? Because you don't want to, for willy-nilly, if I'm changing a button on a screen, you may not want to put that feature request to threat model. But if you're changing architecture of a system, or if you're supporting, or if you're containerizing your microservices, you may want to go through a more rigorous kind of design review. So understanding that trigger is important. So that's the second thing. The first thing is the understanding what threat modeling process and approach. Second is the trigger. And third thing is how do we measure? So something about reporting and matrix. So we need to establish at least some basic level reporting in terms of what do we need to report? What do we need the reports to tell us so that we know how we can improve our processes? So at least those three things you can start with in the operating model. So we talked about body of knowledge and operating model. And the third thing is the delivery capability itself. And we can talk about that. But really, that is where I'm seeing a lot of changes from our clients, that whereas threat modeling 5 years ago was a totally separate process, today the thinking is threat modeling should be continuous in nature and not more, as I call it, episodic. But you want it part of your SDLC. And it needs to go from being a gate to a guardrail. And that's where the transition is taking place. So threat modeling is more becoming guardrail. It is becoming continuous. And as a result, it is becoming to some extent transparent to developers. It happens as part of SDLC. And that is the best threat modeling that you can have, because you need to maintain the pace of change today. So the delivery model is kind of changing for threat model.
How do you build that body of knowledge? Like you've developer, you do have that. How do you build that?
Yeah, it's a good question. I think the way I see becoming a security architect is you need to have interest in software architecture. And a lot of people do not know what software architecture is or why design is required. So what is software design? What is software architecture? Why is it required? And I always go back to the basics. So when you came out of the school and we wrote everything in C, if someone were to tell me to create a program that achieves a certain function, for example, I can write that whole program in the main function of the C, okay? So what people need to understand is that to deliver functionality, you don't require architecture and design. Architecture and design are all the other LETs like maintainability. Can I maintain this piece of software? Well, I cannot, because it's like one giant function that is like 4,000 lines long. Oh, okay. So I need to like make it modularized. Okay. That's a design choice. Does it perform well? So performance. Oh, it doesn't perform well because it is not multi-threaded. It is not containerized. It is, so now you're talking about designing a software that can perform well, that can be maintained well, that can scale well. So all these things, security, scalability, performance, maintainability, all these ities is the source of design. That is what design is all about. Design is not about functionality. So once you take interest in architecture, then you start becoming, that's the first step in becoming a security architect. And once you understand architecture, then what a security architect really requires, what I call is more breadth of knowledge and less depth of knowledge. So if you look at a pen tester, pen testing is a craft that requires mastery of detail. You need to understand HTTP headers. You need to understand how a GET request looks like, POST request looks like, response looks like, redirect looks like. You need to understand at the byte level, in fact, bit level in many cases. You don't need that when you look at security architecture, but you need to understand big picture things. You need to understand distributed protocols. And you just need to have a lot of interest in understanding the architecture and have a knowledge of security. And then you're on your way. It's that easy.
I mean, it sounds easy, but I don't think that it is that easy.
Well, it is just like any other
Right.
craft. It just
Practice
requires
and build.
practice. It is no more different than being a pen tester. I don't view that as any different.
I mean,
So
I think it's kind of like similar because you still have a framework to do it. You have to actually kind of like think in a different way and then just build that knowledge, right? Like,
correct. I mean, the key in architecture really is, even if there are some anchors, okay, that you need to understand in any architecture. One is security architecture means you need to have mastery of cryptography.
Mhm.
Okay. You need to have mastery of distributed protocols and attacks on distributed protocols, interleaving attacks, replay attacks, what have you, right? They will appear over and over again from Kerberos all the way to OpenIDC, right? And you need to have understanding today of cloud, because cloud has effectively become your go-to model for deployment. And Kubernetes, if you don't understand Kubernetes, that is the modern computer. Kubernetes is the modern computer because today's developers do not need to understand how to scale something, right? So when I used to program back in the day, we used to write multi-threaded programs with semaphores and stuff like that. Today, developers don't need to understand any of that. They just write a class and they throw that class at Kubernetes, and Kubernetes scales that class in a container magically.
Yeah.
You know what I'm saying? So you need to really understand Kubernetes because that is the modern day computer. So, I mean, those things have become key. Kubernetes is the key today. Without that, you cannot understand how software is deployed. Cryptography is the key. Understanding of distributed protocols is the key. So those are some of the anchor points, and you can use those to kind of move up the ladder.
Interesting. So, Chandu, I do have a question for at least, let's say, from doing the threat modeling. Is it safe to say that we always would like it to be part of SDLC from the beginning, like you do it from the design side, where you're actually doing this threat analysis? But what we see mostly that this is not happening, right? Like it's kind of, as you mentioned, it's episodic. It only happens once, and sometimes it happens at the end, or maybe like while the project is already live. So what challenges you get with these type of projects where you actually are doing it late in the phase of the project that you might actually cause a re-architect that's happening, but then there will be some issues. So
Yeah, I mean, that is what, unfortunately, the status quo in the industry is today. And it is expensive. So if a system is live, and if you conduct threat model of that system, and if you found some flaws, we all know it becomes very expensive to go back, fix those design flaws, retest again, redeploy. I think it's a big expense. And in many cases, since the system is already deployed, um, maybe redesign is not possible or it is put off, and people work with workarounds, which create their own problems. So there is a lot of value in building something right from the get go. Because if it is not built right from the get go, then the options later on can become expensive and can compel us to create workarounds in many cases. So you really don't want to go there. And just to complete that thought, there are many systems out there which are already live. So it is natural for most companies. I mean, we always advise that any of your critical applications, you should establish a complete threat model, a baseline threat model, at least once every year, once every n months, or a major release. But as you start making changes to these systems, then you need to start looking at building those things right from the get-go. So at that time, you want to really think about bringing the secure design discipline and culture within your sprints so that your sprints are ahead of the curve in identifying security requirements, in addressing secure design, and so on.
Okay. And so one way of moving that from kind of the big episodic threat models to the integrated transparent is through the use of like right-sized checklists that developers can apply, or are there other methods?
That is the most common method. So if you look at tools like SD Elements, they have taken a crack at that. And SD Elements is not a threat modeling tool. I just want to bring it up in this context because SD Elements tries to identify security requirements for a given application context. So that to me is a good start. Now, we can take that concept a little further by saying we can do better than just identifying security requirements. So when you're talking about, let's say, SAML, you want to make sure that you can identify design requirements. So you can say that, hey, if it's a SP-initiated SAML flow, then every authentication request needs to adhere to 4 security best practices. That the request must be sent using an ID that is generated using secure random processes. We must use issue instant, for example, so that we can minimize replay types of attacks. We must sign the request. We must transport the request on TLS, and so on and so forth. So we can start going into a little bit more detail so that developers can actually get actionable design guidance using those checklists. And Synopsys has built over the years a database of secure design checklists, since our consultants are going around and looking at the same problems over and over again. And I always tell my clients that whether I'm looking at a biomedical engineering system, a financial system, a telecom system, a healthcare system, SAML works the same way, Kerberos works the same way, containers work the same way, and Kubernetes works the same way. So yes, there are certain domain-specific threats I need to be aware of. However, 80% of the value I can get in simply decomposing your system and understanding security best practices for each of those components using well-established security best practices. If we just did that, we get 80% of the value at 20% of the cost. So we have built a large database at Synopsys that the army of consultants we have use. So we use our own dog food, and a number of consultants, a number of clients we have engaged with, also have started using our database. And I always say good for them, because they will help us continuously improve our database, just like our consultants do. So that's a great way to get started.
Okay. Right. I guess it's a little bit easier than kind of going back to your aircraft analogy. There's a saying that FAA regulations, and I'm going to add checklists here, are written in blood. So that probably sounds that's probably a little bit less bloody than responding to incidents and doing stuff the hard way.
Yes, absolutely. You're absolutely right.
All right. And so if you were setting up a threat modeling practice with a client, and they wanted to judge success, you mentioned metrics earlier, that you want to measure kind of your threat modeling program over time. What metrics would you listen out for, and what would you want to see go?
Yeah, that's a great question. So when we are a successful threat model means really we are finding less and less design level issues in our security testing, penetration testing, or in our incident responses. So it is one thing to find a misconfiguration, for example, for a container or for some cloud service. But it's altogether a different thing to find a design flaw where we are using the wrong crypto control or a crypto primitive. And so that takes a lot more effort and money to fix versus a configuration change. So the one metric I always suggest to our clients is any issues found in security testing, penetration testing, incidences in production. We want to tie them back to see which of these are fixed by fixing the design versus which were implementation level issues or configuration level issues. And our goal should be to really minimize the number of design issues that we find later in the SDLC. If we can get there, that means our program is working well. I mean, this is what I call quality metrics. So if you look at the classic CMMI metric stuff, this is the quality side of the matrix, but there's an efficiency side of a matrix as well, which is how many projects are we handling through our threat modeling program? How many new applications are we handling? What is the size of our team? How long does it take us to threat model something? Can we reduce that time? So there are a lot of efficiency related metrics as well that we can use. But I usually focus on quality metrics first and then efficiency metrics.
So I want to ask about the triggering, since this is also can come from the metrics, where if you see that you're taking too long or you're not covering, let's say, a lot of apps, would that feed back to your triggering, let's say, questionnaire or checklist? Let's say, like, if this application has to go through this pipeline of doing the architecture review, or we have to pass it, is that something can be feedback through the metrics?
Yes, it should be, because that is how you enhance your patterns database. So typically you start with a set of patterns, and all these patterns are giving you two things. They are giving you, or let's say checklists are giving you two things. They are giving you consistency in your analysis, but they're also giving you efficiency. So if I'm getting applications that suddenly are using a service mesh and I have never looked at service mesh, then it's going to take me some time to learn about the service mesh like Istio, to see whether I'm using the service mesh correctly, what are the security best practices, what are the threats, what are the configuration challenges. So it's going to slow me down. And that should be a trigger to say that why can I make it better next time? Like, are we getting many applications that are going to get deployed in the next few months using the service mesh, because that's the company standard. If yes, maybe we need to just build a checklist for using Istio. So a metrics like that can really help us identify how we want to enhance our patterns database.
Okay. Another question regarding, let's say you have a new, as you mentioned, like new projects, like you don't have any standards on it, no blueprint, nothing comes into your pipeline saying, okay, let's go and do that. Do you initially think of building the blueprint and say, okay, we're dealing with, let's say, this technology that we haven't done it before? Do you think immediately of trying to standardize it, or you treat it as one-off?
Yeah, I would say that the answer is it depends. So if you look at the principle of pattern checklist based approach, a pattern is a commonly recurring problem whose solution you want to create once in form of a checklist and reuse it. So let's say, and this actually happened to me at a client, that they bought a company, and when they acquired this company, the company had totally different technologies within their applications. And the question arises, like, should this client that acquired this small company, should they build a pattern for that? Should they build a checklist for it? And the answer most likely is no in this case, because it's a one-off thing. It is not a recurring problem for them. However, in some cases, the example of service mesh that I gave you, it could be a company standard that, hey, we are going to use a service mesh like Istio. And in that case, you get the first application, then that's a trigger for you to say that, should we build a pattern for it? And in this case, the answer should be yes, because yes, the company has decided to move in that direction. So most applications will be using service mesh in the next year. So we should be prepared for it. So really, pattern is making a judgment call, knowing what you know at that point in time, whether this problem is going to recur, and whether creating a pre-baked solution in the form of checklist gives us enough efficiency in the long run.
Okay. And what about, let's say you have a new project that comes in, and do you immediately think of doing a very big threat modeling activity, or you start with, like, let's say doing just security feature review? Like, how are you going to base your level of efforts based on the new project? Like, how's that done?
Yeah, so again, it depends. So we always advise our clients to have, I talked about in the operating model, a trigger. At what point do we decide threat modeling is required? Now, this is a trigger question. So a company could decide by saying, well, if it's an externally facing application that uses our crown jewels, for example, or gives access to our crown jewels to our customers or partners, then I want this to be threat model. But if it's an internal application that is not using any of my crown jewels, then I can simply either delay, or I can simply do a cursory feature review and move on. So you could, in that case, triage your projects and applications and say that, okay, this is a low risk application for the company, this is a medium risk application for the company, and this is a high risk application for the company. And clearly, for high risk applications, you want to conduct threat model, a full threat model, I would say. But for low and medium, based on your risk appetite, you should always do security feature review. But then you can decide what is the frequency of threat model. For low risk applications, maybe you never want to threat model those. But for medium risk, maybe you want to threat model those once every few years. So you can build that sort of a framework as part of your trigger mechanism.
So you think so security feature review should be always there as, like, in terms of capabilities that been offered. Is that what, like, the ideal situation?
Absolutely. Absolutely. I mean, that is like the most basic thing that we should always do for all of our applications: low risk, medium risk, or high risk. Um, and then as our risk level increases, then we can add a little bit more deeper uh, design reviews to it, including threat model.
So, in terms of, let's say, getting that application toward the SDLC process, where you're actually having that as part of the project, let's say release, enrollment, there are some tools that now they are kind of integrated to the pipeline. I'm not sure. I mean, like Threat Modeler is one of them that can offer that capabilities. I mean, it's still kind of like a separate process, but you can still initiate that. Have you dealt with any client who's doing that?
Yes. So, tools is a very interesting topic in and of itself. And this is just from my experience. So, tools are only as good as the knowledge that they bring to bear that is relevant to you. Okay. So, a lot of these tools, so let's talk about, like, I have looked at Threat Model or Areas Risk are the two tools I have looked at briefly. Some of our clients use those. There is definitely a big adoption curve for these tools because it's a new tool that security folks as well as engineering teams have to learn. Second thing is these tools have to be customized to your enterprise's context, the technologies you guys are using, the protocols you guys are using, the deployment methods you guys are using. So some customization can also kind of add to the cost of these tools. Having said that, assuming you're well trained on using a tool and assuming the tool content is customized to your context, then those tools will certainly give you efficiency. There are no doubts about that. That is what I have seen. I have also seen many of our clients who have bought the tool, but were unable to make use of those tools because somehow they were not able to customize it to their context, or the tool was an island, was not integrated into their SDLC really well. So there are some challenges in tooling, but I always tell clients that you should have your threat modeling process, your body of knowledge, and then you should bring a tool that fits that process and that body of knowledge. You should not start with a tool and then work with the tool to adjust your processes and body of knowledge. That's the wrong approach. So tool comes at the end, and all that tool is giving you is efficiency. If you do the two things that I told you the right way.
Right. So what should they be looking at for this tool? Like capturing a way to automate and enforce their workflows, or to capture kind of their knowledge into automated rules?
Both of those things. And for example, and I know that Synopsys doesn't have a tool, and I'm not biased against any tool, or I'm not for any tool. But what we have seen that is getting traction is we have a Jira plugin, because Jira is a commonly used tool by most developers. So you could create a tool in Jira, and I believe I may be getting the company wrong. I think Netflix has done that, and they have open sourced it. And I should have remembered the name of that tool. Or Slack. I think Slack did that. So Slack has built this Jira plugin, and Synopsys also has a Jira plugin. And the ideas are very similar, that at the beginning of your sprint or development cycle, you answer a few questions about your sprint or the application or the changes you're making. And based on that, you get security requirements, design guidance injected as Jira tickets so that it becomes transparent to the developers. So the big issue with tools like Threat Modeler and EDS Risk or even SD Elements is that they need to integrate with your SDLC tool like Jira, for example. And some of these tools do integrate. But that is what we need to really bring to bear is how transparent are these processes to developers. And the Slack's tool is, in my mind, a good way to make that transparent, bring those checklists and design guidance transparently to developers so that security requirements are injected as Jira tickets transparently.
Interesting. I mean, you could really put that as part of the requirements, like as you mentioned, like answer the questions to trigger certain tasks that you have to perform. But at the same time, the developers don't have to go or hop into a different system to actually implement that unless it's really necessarily needed. Like I don't know if there's like a well integration between the two tools. Yeah. But can we use the tools as part of discovery? Like, let's say, as you mentioned, like the client acquire different products and they don't know anything. Can they use the tools to kind of like speed up the discovery for the architect, or like they have to do kind of like the interviews and collect the data there manually? Like, which are you in favor with?
I mean, if you were to ask me in a utopian world, yeah, I would like tools to discover and tell me, and instead of me interviewing, that's clearly the answer. That is pretty simple. I just don't know if there are any tools which are very effective at that. IO, for example, is a tool like IO could eventually get there because it has access to your check-ins and it has access to your dependency trees. Black Duck is kind of, I mean, these are all solving different facets of this problem, saying, I will do dependency analysis, like in case of Black Duck. IO is looking at more than just dependency. It is also looking at your check-ins and trying to figure out what testing you need to do. But a tool like that could also be extended eventually to say, hey, I'm seeing that you guys checked in some stuff now that tells me that you guys are using OAuth for authentication and authorization, which I did not see before. So therefore, I suggest that you guys should be looking at this design guidance. So there could be some of that could go on with tools like IO. But I think that is in the infancy or early stages.
So when you're implementing this, how do you know, or what feedback should you be getting from your developers and architects and team members that your rollout is going well, that your tooling is working, your process is good, that friction is low? What feedback should you be looking for if things are going well, and what feedback should you be looking out for as maybe a warning?
That's a great question. And it has been one of my pet peeves when I came into security consulting some 9 years ago. I was a developer for most of my career before then. And in economics, there's a paradox, actually, principal agent paradox in economics. And that it really means that if you look at a big company like Yahoo, for example, the principals of the company are the shareholders. But the agents are the management. And sometimes, and the principals have to get everything done through the agents. Right? The shareholders can only wish, but the management does everything. So sometimes there's a conflict between principals and agents. And in case of Yahoo, everyone knew that Yahoo shareholders wanted to sell the company to Microsoft, but management was not part of that, on board with that. So in any case, so in economics, it's a very well understood paradox called principal agent. When I came to security, I realized that we have the similar paradox in security, that the principals, the people who own the security problems are the various SIGs, the security groups. They understand what is the right way of doing things, right design guidance, right coding guidance. But the agents of change are developers. So we have to work with software developers. That's the only solution we have, because that is the only agent of change we have. So in the beginning, at least, I saw that there's a lot of friction in many cases between the principals, the security folks, and the agents, the engineering teams, or the developers. And if you look at today's DevOps, DevSecOps journey, it is really solving that problem by saying engineering teams are at the center, and we need to do everything to enable, to streamline, so that when a change is done, all the cross-cutting concerns are just taken care of and it gets deployed. So in this model, I know it's a long-winded answer. We need to make sure if developers are complaining, then that's the first sign that we are not doing something right. And this happened to me at a couple of clients. They were using tools, and I won't name those tools. And the tools were selected by SIG groups, and the developers thought the tools are not giving proper advice. Their recommendations are too generic. They are not actionable. There are cliches. So developers saw this as an impediment to doing their business, to making changes to the software. And when that happens, then we need to be cognizant of that. The other example of that is IDE-based security tools. It's a great idea. There was a rage up, a few years ago. And in fact, even our company had a tool that worked in IDE. Anyone who understands software development would tell you that IDE-based tools are unlikely to succeed in the long run because it impedes developers. So we really need to work with engineering teams, understand software development process, and make sure that we are really helping the software development teams do the right thing transparently if possible. And that's how we succeed in this game.
So you kind of answered the feedback when you are trying to make sure that there is some kind of war like you should be more careful in your process. But the successful feedback, let's say that you know that your program is actually doing well, is it when some developers come back and or like you don't see any repetition in terms of like any design flaws, or like that efficiency metric is actually showing good results? Like, is that the things that we have to look for in terms of the feedback, or what for a successful program?
Yeah, for a successful program, we need to look at not just the efficiency metric, but also the quality matrix. As I explained earlier, that we want to make sure that our program is really finding the right things, which are design flaws, and fixing them early in the game. And you find that, as I explained, by designing quality matrix on the types of things you're finding in security testing, penetration testing, incidences in production. The other goal of your program also should be making it as transparent to developers as possible, or engineering teams as possible. And that's where the journey from being a gatekeeper to guardrails is kind of the move these days, that we are no more acting as gatekeepers. Like 5-7 years ago, security teams would sit on the ivory tower and say that, okay, when your design is ready, thou shalt send me your design, and I will do magic threat modeling and tell you what is wrong and what things you should fix. But those days are kind of numbered now, and more people are moving towards the guardrail model, where we are becoming more transparent to developers by providing them tools and body of knowledge so that they can do the right thing from the get-go.
Right. So it's kind of like, as you mentioned, to have kind of like open conversation with them, to actually connect with them. And once they know that they will approach you for any, let's say, new technology, looking for best practices, and that actually can help them achieving the checklist or making sure that they are not designing something flawed from the beginning. So it's kind of like building that security mindset.
Correct. Building the security mindset. So if you look at various maturity models, and I liked Microsoft's SDL optimization model, where a mature organization is where engineering teams are really doing the heavy lifting when it comes to secure design and threat modeling. And security groups are acting as mentors, just like you said, where if they have a question, they can reach out. If they want a new pattern, that they can reach out, a new checklist they want to build. However, for day-to-day operations, the engineering team should be enabled to conduct secure design and threat modeling.
Do you see any challenges, let's say, towards to reach this moment? Like any challenges, let's say, because I think most of the people have the issue with the resources, right? Like the staffs, like the number of, let's say, engineering that supports number of applications and stuff like that. Like, how could we like achieve that or like overcome this obstacle?
Yeah, so that's a very common problem that companies have, is that they have 6 people, a staff of 6 in the security architecture group, and they have 2,000 applications. And the only way you can surmount that is by building a body of knowledge, by having a process, by enabling engineering teams, by building a security champions program. So we talked about the delivery model of a threat modeling program. Security champions could be one of them. So that's how you scale a program. You cannot scale that in a top-heavy organization. You need to push it down to the edges.
Yeah.
And that means enabling using everything we talked about, enabling by defining processes, defining triggers, having a body of knowledge, having a security champions program. And now you're suddenly beginning to scale the program more efficiently at the edges of the organization, while the SIG group is more and more acting as the brains and as the mentor.
Right. So it's not like a silos or like everyone is doing their own things and or a bottleneck.
Correct. And correct. And I think you also talked about culture in between, and culture is a big thing that SIG can bring to bear in this case by having brown bags, by having security groups, by discussing current attacks. That's how you create this culture, so that everyone is kind of watching out for security, interested in security. SIG can help promote that type of culture as well. But that is besides the point. I mean,
that is all we're going to say about that for now. Where can we find you? Do you have anything you want to plug?
On LinkedIn, that's as far as I go. I don't. I used to tweet, but I have gone away from Twitter, so I'm mostly on LinkedIn. I have some blogs on Synopsys.
Great, thank you.
All right, thanks, guys. It was a very interesting, exhilarating, exciting talk, and thanks for giving me the opportunity.
Oh, thank you.
Mm-hmm.
It was really interesting.
Okay.
Yep. We are trying to grow this little thing to help the community. If you got something out of this and know anybody who could benefit from what we're saying here, please share. Word of mouth is everything in this business. If we're awesome, tell a friend. If we're not, tell us how to get better. Please reach out to us via Twitter at AppSecMC or subscribe to our podcast in your podcatcher of choice. Our website is www.appsecpod.com. The music is by Lobo Loco. We're talking about security topics that might be helpful to you, but this is really just a chat. Please don't take this as gospel. Be safe and secure, everyone.